G'day, we're looking at our last video in this series of trigonometric functions. We've looked at horizontal functions before with sine and cosine, and we're going to be looking at horizontal functions with tangent. It follows that same pattern. Last video we looked at translating or dilating the period in a tangent function. And this time we're going to be looking at translating or dilating the horizontal axis. Now, a lot of the times, whenever you get calculations or diagrams, you generally get a range, 0 to 2 pi, or 0 to 3 pi. And the reason why they give you those kind of ranges is because you know you're going to be moving the diagram either to the left or to the right in these cases. Well, when it comes to periods in terms of changing your functions, we like to break these things down into 4 different points. We want to know what the period is, what the scale is, how much is it moving for each section, what the horizontal translation is, and what the vertical translation is. And once we work all those out, we can then start sketching an accurate graph of what this should look like. So let's have a look at this calculation here and start sending out all the information. So remember, when we look at period, when it comes to tangent, the period was pi over b. However, this time we don't have any value but 1 here. So therefore this here will be pi over 1, which is equal to pi. So therefore we've got a range of pi, that doesn't change. We've got a period of pi which hasn't changed. To find the scale is we do period divided by 2. And the reason why I say divide by 2 is because when we looked at the graph last time, it just changed. It's just horizontal asymptote, x-intercept. Horizontal asymptote, x-intercept. So there's just basically 2 things that are changing. I didn't have to divide it by, you could divide it by 4 if you want to get those really accurate points in between it. But we're only worrying about in this course here where the x-intercepts and the y, the x-intercepts and the horizontal asymptotes lie. So in this case, your scale is going to be pi on 2. So that is going to be our answer for your scale. Our horizontal translation, remember, x plus pi on 2 is equal to 0. Let me see. Yeah, it's pi on 4 actually. Sorry, not pi on 2, pi on 4. So on pi on 4, so therefore x is equal to negative pi on 4. So that means we're moving to the left in this instance. And our vertical translation, well, we don't have any. So where are we starting? Well, we're starting at our pi on 4 here. So because we've got positive pi on 4, we're going to be moving in the opposite direction. So we were usually at pi on 2 here, so we're going to start here at pi on 4. So therefore, this here will be our first horizontal asymptote. Okay? Because we're moving a whole pi across, then this here will be negative pi on 4. But we're not worrying about this here because we're going from 0 up to 3 pi. So, what are our next points going to be in this graph? Well, I said that my scale is pi on 2. We know that we have to add pi on 2 for every point that we move along. So our next point is going to be an x-intercept, then a y horizontal asymptote, x-intercept. One way you can work around this here is, well, this here is 4 already, and let's make that nice and clear. Why don't we just make this here 4 so we can add it quickly? So therefore, this here will be 2 pi on 4. How do I get that? Pi on 2 plus a period plus pi on 4. Well, I have to times this here by 2, so therefore 2 pi on 4 is the same as pi on 2. Well, what does this do? Well, that just tells me now that even though it's a period of pi, I'm moving each change up by pi on 4. So therefore, pi on 4 plus 2 pi on 4 will give me 3 pi on 4. So I can type here 3 pi on 4. And that is my x-intercept. Okay? 3 pi on 4 plus 2 pi on 4, 5 pi on 4. And there is my y on my horizontal asymptote. Next one, 5 pi on 4 plus 2 pi on 4, 7 pi on 4. There's my horizontal asymptote. Next one, 7 pi on 4 gives me 9 pi on 4, so there's another horizontal asymptote. And then 9 pi on 4 plus 2 pi on 4 is 11 pi on 4, which then gives me my x-intercept. Now I'm not going to go any further because anything past pi on 4 is going to be beyond 3 pi here. So what we can do here is we now can sketch this. We can say, well, here is what my graph should look like. So we have started from our position where we had pi on 2 and we've moved back pi on 4. So that's your first horizontal asymptote. We can double check and see, well, does this make sense? Our period should be 1 pi. 5 pi on 4 minus pi on 4 gives me 4 pi on 4, which is the same as pi. So the period indeed is 1. So we know that it works. So let's now identify what our asymptotes are and our x-intercepts are. Where our asymptotes in this case is going to be pi on 4, 5 pi on 4, 9 pi on 4, and that's it. Your x-intercepts are going to be 3 pi on 4, 7 pi on 4, and 11 pi on 4. And that is how we do a horizontal translation with tangent. So the key things here is try and break it down into these 4 different parts. What the period is, what the scale is, what are we moving up for each joining part. Remember, horizontal asymptote, x-intercept, horizontal asymptote, x-intercept. If we have a horizontal asymptote, horizontal translation, what's it going to be? If this here was, say, 1, then we move everything up 1 and stay in that same position. Well, that's going to bring an end to our trigonometric function series. Our next video is all going to be about how we make some algebraic substitute equations and solve them. I'll see you then.